SwayamPrabha. Digital India. Educated India.
So, friends, in this course of production and operations management, we are talking about inventory management. In the last unit, we talked about the importance of keeping the inventory in a manufacturing system. At the same time, we discussed that keeping inventory is very expensive, and so one should try to keep as minimum inventory as possible. Further, we deliberated that as the variety of the products increases or the new product introduction is very fast, new models are launched very fast. In that environment, responding to the market requirements with inventory is very expensive. In that case, we have to develop our processes in such a manner that we should be able to meet the requirements of the customer through the processes. So, here in this unit, in this today's lecture, we are talking about just in time manufacturing philosophy. This is not only a inventory related policy, it is a very holistic philosophy of manufacturing, but the crux of that philosophy is we should try to reduce the inventories, we should take the measures on factors which force us to keep inventory, whether it is due to large batch sizes or large quantities to be purchased, or due to uncertainty in supply, or due to uncertainty in demand, or any other factor because of which we are keeping the inventory, or it can be poor maintenance also, it can be quality related issues also. So, we should take countermeasures on those factors rather than building the inventory for that. So, rather than taking a reactive approach of inventory management, we should work on reducing those factors which are more as a proactive approach. The problems which are there in the system, we should try to resolve those problems rather than building the inventory for them to cope up the situation. So, this is going to be our talk about this just in time manufacturing system, where we will see that how we can work out a system where through which the inventories are not required. We should work with the zero inventories or close to zero inventories. If we recollect in our previous session, we are going to use those also. So, I am just reproducing them. In our inventory management, we studied several models of manufacturing, models of purchase also, and one basic formula which we used very frequently there was economic order quantity, which is given by 2 D CO by C I, where D is the annual demand of the item, CO is the cost of ordering, C I is the cost of carrying inventory, okay. And if we are placing the order equivalent to economic order quantity, the total cost of the system will be 2 D CO into C I. Okay. Then we also determine the safety stock required. If there is a safety stock required, if there is any uncertainty in demand or uncertainty in supply, and this safety stock is equal to Z into sigma, where Z is related to service level. Higher the service level requirement, more is the value of Z, and sigma is the variability. It is a variability in demand or variability in demand and supply. So, we will see that how to address these issues, so that I need not to keep the inventory, I need not to keep the safety stocks, and I can respond to the changing requirements through the processes only. So, with this background, let us start understanding the concept of just in time manufacturing system. I am showing you 4 definitions in 4 slides, and then we will comprehend that. So, first concept about JIT is produce and deliver finished goods just in time to be sold. So, you are producing the finished goods only after receiving the order or when there is a customer ready to purchase, and then to make the finished goods we fabricate the parts just in time to go into sub assemblies. So, whether it is a welding part or painting or engine parts or machining or something, we are doing it when it is going to be used for sub assembly, engine assembly, or it is used for painting purpose, or it is going to be used on the line, assembly line, and purchase parts just in time to be transformed into fabricated part, and we do the purchasing only when it is required to be fabricated or it is to be used in the assembly operations. So, we are doing the activity at the latest possible time. Just in time means when it is required, at the latest possible time we are doing this. First concept. Second concept, JIT is a philosophy of organizing the work. If we want to do the work at the latest possible time, just in time, we have to organize the work. We have to organize the work with the ultimate aim of increasing productivity and flexibility. So, we have to our work center should be highly flexible without compromising on the productivity. So, we have to develop our workstations which are highly flexible, that means they are in a position to respond to the changing requirements, and through eliminating the waste. So, they should be efficient also and without compromising on the quality and with the improvement on the quality also. So, here in this definition you will find we are talking about flexibility, we are talking about productivity, we are talking about quality also, and as a just in time we are saying delivery has to be at the right time and production has to be as late as possible. So, in general we say that our aim in production management, I discussed in introduction also, is threefold. One is quality. So, here also in this we are saying there should be some improvement in the quality. Then we are saying efficiency, removing the waste and increasing productivity. So, we are talking about the language of cost also, and we are also talking about with the help of flexibility and just in time, we are talking about the delivery also, on time delivery also, just in time delivery. When the material is required by the customer, we are in a position to supply at that point of time. So, let us see one more concept. So, here the keyword in this, if we want to note, is organizing the work, whereas in the previous slide the keyword was doing the activity as late as possible, only when it is required by the subsequent stage. Subsequent stage can be customer, it can be assembly, it can be sub assembly, it can be fabricated part fabrication for the bought out components or parts. Now, let us see third. The objective of the JIT is creation of smooth and rapid flow. So, how to organize work? Organizing work means creating smooth and rapid flow of all the products from the time the raw material is purchased to the time the final product is shipped to the customers with 0 defects. So, the keyword here in this definition is we have to organize the work in such a manner that there is a smooth and rapid flow. That means, it is a integrated flow, there is no interruption, no disruptions in between, and it is rapid also. It is not that very slow pace you are working, you have to look at the productivity also. So, it is a seamless flow, integrated flow without any disruption, interruptions in the system. So, we have to develop our production processes, manufacturing processes in such a manner that there is a smooth rapid flow right from the beginning to end. The moment material enter into the manufacturing area till the finished goods leave the manufacturing area, all stages should have a very smooth and rapid flow, and that is possible only by having the flexible equipments and very capable and available equipment. There should not be any maintenance problem, there should not be any quality problem, there should not be any workers related, training related problems or any such issue. Material flow should also be very smooth. The input components and parts which are required, they should be readily available. So, all these things are required to create a smooth and rapid flow of the products from the beginning till the end. Let us see one more definition. The purpose of the JIT is production of the smallest possible quantity. So, if we are having the rapid and smooth flow, So, I can produce the smallest possible quantity. That means, if there is a customer who is asking for 1 unit, I am in a position to produce 1 unit efficiently without any loss of, without any increase in the cost and at the latest possible time. So, that is the crux of this. We should be able to produce the smallest possible quantity at the latest possible time using a minimum of resources. So, we are talking about the language of productivity and efficiency also. So, the system should be productive, it should not increase the cost in the in providing this smallest possible quantity latest possible time, you should not increase the cost and eliminate the waste in the manufacturing processes. So, with minimum of resources and eliminating all types of waste. In JIT context, we will talk about what is the meaning of waste also. So, what we are talking about here is we should have a highly productive system, highly efficient system and highly flexible system also. So, we need productive and flexible system, so that I can produce the latest at latest possible time in smallest possible quantity without increasing the cost. Now, putting all these 4 definitions together. So, the keyword in the first definition is we should do the activity when it is required by the subsequent, when my customer, a customer can be external customer, customer can be internal customer also. And for that I should organize my work in such a manner that there is a smooth and rapid flow of material. I have to organize my work, organize my machines, organize my vendors, organize my team, maintenance and quality control activities, materials management activities, vendors, everyone, logistics, everyone I have to organize in such a manner that there is smooth and rapid flow of material products from the raw material till the finished goods. And for that, if I am able to do that, I can produce the smallest possible quantity at the latest possible time. So, this is how we can see the just in time manufacturing system. So, now you will get an idea what we are going to discuss in this particular lecture. We are mostly talking about how to organize the work, so that we can have a smooth and rapid flow, or I can produce smallest possible quantity at the latest possible time. So, that is going to be the aspects which we are going to study in this particular lecture today. Now, look at this, this is a Japanese way of explaining the things with the help of analogy. So, we are taking to explain the concept of JIT, we are taking the analogy of river and boat. We are taking the analogy of river and boat. Here boat is our manufacturing process which is meant to meet the customer's requirement, which is meant to fulfill the customer's expectation, and what we want, boat should sail smoothly. Boat should sail smoothly, even though there are rocks at the bed of the river. This is the river and these are the rocks at the bed of the river. We want that despite having all the rocks etcetera at the bed of the river, my boat should sail smoothly in this. So, what is required for that? What we do there? The boat can sail smoothly if there are rocks at the bed of the river, if the water level is sufficient. If the water level is sufficient, boat can sail smoothly without even knowing that there are rocks at the bottom of the bed. In the same context, if we talk about the manufacturing system, every manufacturing system, every service system has large number of rocks at the bed in the company. There are several rocks. Rocks are all kind of problems. Problem can be related to quality, problem can be related to maintenance, problem can be related to breakdowns, problem can be related to worker absenteeism, problem can be delays in deliveries, problem can be related to logistics and so on. Problem can be related to high setup time, changeover time, high changeover time. So, there are endless problem changeover time. So, there are n number of problems in the system, and what we do if there is a delays in the delivery, we keep the cushions, we keep the safety stock of raw material. If we are finding that there is problem of outbound logistics, or the demand of the customer is varying, we keep the finished goods inventory. If we are having a problem of reliability of my equipment or maintenance problem of the equipment, reliability of the equipment, I keep extra buffers in between the two machines, or I keep inventory, work in process inventory between the two processes. Or if there are quality problems, I keep buffers in the form of finished goods, I keep buffers in the form of work in process inventory. So, my answer to all these problems in the organization is to keep inventory. My solution is, the traditional way of looking at these problems is to hide these problems with the help of inventory. So, what I do is I hide the problems with inventory, so that your manufacturing process, your customer service can happen smoothly without any difficulty. So, inventory is like a water in the river. If the inventory level is sufficient, these problems get hidden and your manufacturing process, your customer service can happen very smoothly. But the fallout of this is, there is an increase in cost. There is an increase in cost, number 1. Number 2, which is very important, if these problems are not addressed, the problem size start increasing, growing. The problem, rather than it getting solved, if the problem remain hidden, they will start increasing. The size of the problem increases. Okay. So, this is how you have to look. So, what we do in JIT environment? If I have decided this is my initial stage, if I decided to implement the JIT, what I can do? The JIT solution to this is deliberately reduce the inventory level. Earlier you were having the inventory level higher, you were having this kind of inventory level, deliberately bring down to this particular level. So, from this level to you bring down to at a lower level of the inventory. Now, what will happen if you reduce the inventory in the system? Problem get exposed, problems get exposed. So, if there is a less river in the less water in the river, and what you will do? You will get out from the river from the boat and remove those rocks. So, same way here, we will maybe temporarily we are reducing our productivity and we try to solve the problem. So, once the problem get exposed, our only option available is to solve the problems. Option is to solve the problems, and to solve the problem, once the problems are solved, the size of this problem will reduce, and even the lower level of inventory you are able to sail smoothly. So, this is how the JIT system works. Rather than hiding the problem with inventory, JIT says develop systems to expose the problem. That is a radical change from the conventional thinking. In the conventional thinking, we hide the problem with the help of inventories, whereas JIT says develop systems to expose the problems, so that there is an opportunity to solving those problems. So, that is how this system works. I hope so. All our practices, we are trying to reduce the inventory, so that the problem get exposed and the problem get solved. It is not that you do it overnight, reduce the inventory and then you are helpless. You first develop your systems by which you are able to understand you should have the necessary resources to solve the problem, necessary organizational structures and training and other resources should be available in the organization to address those problems. So, it is not that overnight you have to do that, you have to develop a plan for that, you have to develop teams, steering committees for that, and this is not a short term business. Maybe 5-year, 10-year plans you have to keep in mind to improve substantially on that, but the results are then endless. So, once they are achieved, every time you are getting the benefits of those efforts, those improvements. So, the results are coming all times to come. So, that is the advantage of this. So, friends, the basic idea of JIT is to expose the problem rather than hiding the problem. Inventory philosophy, inventory management system hide the problem. I can give you the example. Suppose there is a uncertainty in supply. Suppose there is uncertainty in supply. In our inventory models, we said that the lead time is 4 days and mean lead time is 4 days and standard deviation is sigma lead time is 1 day. So, based on that you calculate the safety stock and you keep that item. That means, we are saying that the material usually come in 4 days, but sometimes it may take 5 days also. So, you are keeping 1 day of safety stock, just we are keeping 1 day of safety stock also, because sometime the supplier is not able to supply in 4 days. So, we should keep 1 day additional material also. Now, what happens with this? Supplier will get to know that you are keeping 1 day extra material also. So, he will have a tendency to supply you material in 5 days. Rather than 4 days lead time, he will over a period of time he will shift his he will become more casual, careless or complacent, and he will start supplying you material in 5 days, and sometimes it may take 6 days also. Once you get to know that sometimes it takes 6 days also, you will further build up the safety stock. You will further build up the safety stocks. So, your safety stock will increase. So, rather than problem getting solved, there is uncertainty, best thing is you should find out, do the process analysis, why the delivery is not coming every time in 4 days, why it is taking more than 4 days. So, if you can do that analysis and try to find out the reasons for that and try to find out the solutions for those reasons, you will find that slowly rather you will be able to reduce the lead time from 4 days to 3 days. But in this case we are finding that lead time is increasing and uncertainty of the lead time is also increasing, forcing you to keep higher inventories. So, that is how we can address this issue of problem, by reducing the inventory, by going to the process where there is uncertainty or deviations are there, variability is there, we should try to address that. So, what are the objectives of JIT or the objectives of JIT are achieved by what we should do? Number 1, as I said, device system to identify the problem, not device system to hide the problem. Most of the time we develop a system to hide the problem. So, rather than hiding the problem, we should have a system to expose the problem. For that, very good concept has been developed, which is called line stop authority. There is a conveyor which is assembling the car or something going like this, and 2 minutes is the cycle time. Every worker is getting 120 seconds to perform his job. Suppose there is some problem at a particular workstation, this guy is not able to perform his work in 120 seconds and the job moves to the next place and incomplete task move to the next place. He is not able to perform his job in given 120 seconds and incomplete task went to the next workstation. Now, what will happen? The next workstation is not knowing that previous person has not is not able to complete. So, he will add value, another person will add value, everyone will add value to this, and finally, the car is manufactured, but this car is not working. There is some problem in this car. So, it is not working. So, what you will do? You will take it to a separate area, take it to the separate area for rectification. So, there is a cost involved of rectification and there is a delay in the deliveries also, delays in delivery also. Okay, whole consignment is waiting because this car is not complete, this has some problem. So, additional manpower is required, they will diagnose and then they will dismantle, complete this process which remain incomplete, and then they will put back all the components, and then this will be ready for dispatch. What is the alternate in the line stop authority? What we can do in the line stop authority? In the line stop authority, once this person was not able to complete the task, so rather than shifting it as it is, he will put a sticker on it, he will put a sticker on this, and he may also stop the complete line, that I am not able to complete my task in given 120 second. There is a switch under his command, he can press that switch and stop the whole line. Supervisor and senior management will come, they will put the sticker on this particular product, so that other persons are not adding value to it. And then at the end it will be taken out, the incomplete part is done and all the components are assembled, and that is done in a very fast manner, because there is no need of diagnosis, there is no need of dismantling. So, only thing is you have to put back the components which were not done on the conveyor. And secondly, then this diagnosis will start, why this person is not able to complete it in 120 seconds. There may be a problem with the tool, there may be a problem with the material coming from the previous workstation, or there may be some other issue related to his jigs fixture, or maybe related to his training. So, that problem is going to be solved, and then subsequently this issue will not arise. Otherwise, if he is sending the incomplete part, so you will not be able to get that who was at fault or where was the problem in the chain in the assembly line, due to which workstation this problem has came in, you will not be able to find out. So, that is the idea here in the line stop authority, and like this there are several such kind of techniques have been developed by which the problems are identified rather than problems are hidden under the inventory. Second important principle here is attack the fundamental problems. Go to the root cause, like here if there is a problem, this person is not able to complete his task in 120 seconds, find out the root cause of the problem. Root cause can be with respect to tooling, within tooling also find out what is the problem. There may be a problem with the compressed air which is coming to run the tool, the power gun. There may be problem with the sharpening of the tool, there may be problem with some other place, or it can be the training of the worker. So, find out the root cause why this person is not able to complete his task in 120 seconds. Similarly, if there is a problem of the high maintenance of this particular equipment, there can be problem of high maintenance of a particular, there can be problem of maintenance or reliability. There is a one equipment which is getting broke down very quickly, and you are putting all kind of maintenance efforts, but still there is a problem. So, if we want to come to this attack the fundamental problem, the idea is to replace the machine rather than putting all the administrative methods to keeping it in the right condition. The JIT solution to this is replace the machine. So, that is how, so that your machine become highly reliable, you are not keeping any inventory between the processes. So, you need your processes to be highly reliable, available at all the time. It should not happen that the moment you want to manufacture something and you found that your machine is not working, worker is not available, or necessary material is not there, or necessary inputs are not there, then JIT is not going to function. So, that is the second important principle, that attack the fundamental problems. Then comes the third principle, that is identify the waste. In this case also, when we talk about line stop authority also, we have to find out the waste. Waste means any known value added activity. He was given 120 second time, he may be doing something which is not required because of lack of his training, or he may be doing something which is not part of the process, but because of the problem in his tooling, jigs fixture, he may be doing something additional which is not required. So, that is called a waste. Any activity, waste is nothing but a known value added activity. We divide the activities into two parts, one is value added, second is known value added activity. Any activity which consume the resources and do not add the value, that is called known value added activities. So, we should eliminate the waste from the system. Waste is any activity which is not adding value to the system. The fourth very important principle, very useful principle in just in time is strive for simplicity. That means, if there is a problem, if there is some issue, you should not develop a complex solution to that. If you are developing a complex solution to that, that will have its own implication. The maintaining that complexity itself will create large number of other problems. So, develop a solution which is very, very simple. So, in Japanese context, in JIT context, you will find all the solutions which are derived, they are more human centric rather than technology centric. They are more human centric, just like we are saying line stop authority, no technology is involved. Only you have empowered the employee that he can take a decision if he is not able to complete his task. All decision you have empowered him to stop the complete line, and stopping the complete line, if it is stopped for 2 minutes, you are losing one car worth certain revenues, you are losing some revenue, but still that empowerment is given to the worker that he can stop the line. If you find, but it has other long term advantages of doing that. So, this is how they go for the, we will see several examples where simplicity is the key word in solving that, whether it is 5S where human centric housekeeping is done, or whether it is a Kanban system, no technology, no computerization, only a small card is sufficient to develop the material flow, develop the trigger in the organization, what item to be produced and how much to be produced. So, that kind of a trigger with the help of Kanban can be created. There are other systems like end-on, there is another system like Poka-yoke. So, all these systems are very, very simple system which has been developed to support the JIT system. So, strive for simplicity is another very important key word or philosophy in the JIT, that we should develop systems to identify the problem, we should develop system to identify the problem, and we attack the fundamental problem, not the symptoms, but the root cause of the problem. And our focus should be on waste. Waste means all non value added activities, and then simplicity is another keyword. All our solutions should be simplistic in nature, so that it is not complex. Complex solutions have their own implications in maintenance of those complexities. So, now we will further elaborate on this with the help of several tools and techniques which are used in JIT manufacturing context. Before doing that, let us see that how the Toyota production system works. In the Toyota production system, two things are very important. They try to eliminate all types of waste, which is non value added activity, and they have very high respect for people. As I said, most of their solutions are people centric rather than technology centric. They see that how the human resource can be empowered to for the purpose of improvements, for the purpose of better efficiency, productivity, quality and so on. Respect for the people is the key word there. So, let us see one by one. When we say elimination of waste, what they do? Waste from overproduction. Generally in our traditional systems, we say efficiency, machine utilization, we want to produce as much as possible. But in JIT context, in Toyota production system context, when I say Toyota production system context, JIT was developed at Toyota, JIT was developed at Toyota. So, sometimes the JIT production system is also called Toyota production system, was developed at Toyota in 1970s, and still they are working on that to further make the improvement. So, it is a ongoing process, it is a continuous improvement process, and they are still keep on working on this improving the production systems. So, overproduction is a waste in their system, where our traditional system, when we say efficiency, machine utilization etc., we say as much as possible we should produce, but they say that you produce just in time to be sold, you should produce only when it is required by the customer. Then it is a waste of waiting time. If there is any waiting time in the system, if the material is waiting or the person is waiting or the equipment is idle, that is also a waste. Then the transportation, any transportation, material handling, multiple material handling is a waste. Then there is that storage of material, inventory, all types of inventory is a waste. Then the processing waste can be there, your processes are too fast, the processes are highly variable, that is also a kind of a waste. Then waste of motion also, additional motion involved, additional movements required, additional steps required in performing a task is also a waste. And obviously, if the defective products are produced, that itself is a waste. In this context, we can, though we will study as a separate unit also in work study, which was developed in 1930s. There they said that all activities can be divided into 5 activities shown by a symbol. Activities can be divided as operation, where some value addition take place. Then it is inspection, then it is transport, then it is delays, and then it is storage. So, the principles of method study says that these 4 activities are known value added activities. These are known value added activities. These are waste, known value adding activities. So, these are the activities which do not add known value adding activities. So, these are the activities which do not add value, they only consume the resources. So, in the waste definition also we are taking the same analogy which was developed in work study of 1930s, that any type of waiting time, this is nothing but delays, any kind of transportation, inventory, that is a storage, processing waste, waste of motion, even inspection also is a waste. We have not written here. So, we can write another bullet, any type of inspection is a waste. The idea is doing the thing right first time. If you are able to do the right thing first time, there is no need of any inspection. So, in JIT context, in TQM context, we are saying that doing the thing right first time and every time, doing the work right first time and every time. Okay. So, right from the first unit we should develop system, so that there is no question of any defectives and no inspection is required. And let us look at the respect for people. When we are talking respect for people, the Japanese organizations, Japanese people, Japanese society has a concept lifetime employment, whereas in the western culture and same is true in the Indian culture also, people keep on hoping the job after every 3 years, 5 years. Their concept is that if you want to grow, you have to keep on changing the organization. Whereas, in the Japanese context, when they have respect for people and there is a trust and honesty, they say lifetime employment. Person has joined the organization at the age of 20 and he is working till he is in a working condition, his health permits. So, lifetime employment is there, they are not hoping the job from one organization to another organization. Important contrast between western concepts and the Japanese context is, if I compare Japanese and western, we are more close to western concepts. In the Japanese context, they join one organization, they work throughout their life in one organization only, but here we keep on changing organization, keep on changing the organization. Second important difference, I will start from here. If your first job is in marketing, throughout the career you will remain in marketing. If your first job is related to production, you will remain in production throughout the life. If your first job is R&D, throughout the life you remain in R&D in different organizations. So, you are stick with particular function, but you keep on changing the organization. Whereas, in the Japanese culture, they stick to one organization. For first few years he is working in production, then he changed to R&D, then maybe change to marketing, then maybe change into finance or HR or something like that. So, in their lifespan they keep on changing the functional areas, but remain with one organization, whereas in the western culture they remain with one functional area, keep on changing the organization. There are pros and cons, I am not defending that which is good or which is not good, but these are the two radically different concepts, radical different culture in two different parts of the world. So, we have to see that what are the advantages. The main advantage of this, when the person is in one organization and changing the functions, advantage is when he is working in R&D, he knows the limitations and the capabilities of production area. When he is working in the marketing, he knows the capabilities of R&D, he knows the capability of production, and if there is any problem, he is in a better position to give the feedback. But no specialists are developed, whereas in this case we are able to develop the specialist. He is a marketing specialist, he is a manufacturing specialist, he is a procurement specialist, and so on, or a person is a HR specialist. But in this Japanese culture, there is no concept of developing the specialist. So, that is the contrast. Moving forward. So, lifetime employment is one important aspect in the GIT system, in the Japanese culture. They maintain the level payroll even when business conditions deteriorate. They do not fire the people if the production levels are low or the demand is low. What to do with this manpower if the demand is less? They are doing offline activities, maybe learning more skills. They are learning additional skills, they are becoming more multi-skilled, learning skills, that can be one thing. They may be doing some kind of a Kaizen activities, improvement activities, improvement of their tooling, improvement of their machines, improvement of their manufacturing methods, or something like that they are doing, or they are. So, you will find, you will be surprised to know that their machines etcetera, the equipments etcetera, every 6 months you will find they are changed a lot. You may not be able to recognize that this is the same equipment which was used 6 months back. So, they keep on doing all automation, all flexibility on that through in-house efforts with the help of Kaizen and other small group activities. So, all these improvement in the technology, improvement in the processes happens within the organization, rather than purchasing the high end technology, they keep on improving their existing technology. Then they do not have the trade unions, political trade unions, just like in India we are having, they are having the company union. That means, employees of the company form their own association union, and which is supported by the management also. It is not that it is a political national level political parties having the trade union, because these are own company employees, they are best people to look after the interest of the employees as well as the interest of the organization. Then bonuses are also given, and they are looking the workers as assets, not as liabilities. So, this is the fundamental difference between the culture of the organization as far as human centric processes, human centric manufacturing systems are concerned. So, let us see what is meant by waste in JIT. So, that is going to give us the direction about where to do the improvements, from where to eliminate or reduce the known value added activity. So, number one is defective goods. If you are not able to produce right the first time, that is a waste, that is a big waste. Every organization understand that, appreciate that, and try to do the things right the first time. So, we have to develop for this purpose maybe kind of a POKA we will discuss, or improve the technology, improve the training. This can come through training and technology. You can reduce the defects through training and technology. So, these are the two important drivers for every purpose, whether it is quality, whether it is productivity, whether it is on time delivery. So, you can take the help of training and technology. So, here also, so we should try to find out why the defective item is produced. It is due to human, it is due to raw material, it is due to machines, tooling, or any other reason. Then overproduction is also a waste, overproduction is also waste. Your material need to be supplied on Friday and you have produced it on Tuesday. So, next 3 days you have to find a storage space to keep this material. So, that is a waste, all storage is a waste, too much. demand was of 500 units and you have produced 550 units. So, this 550 units you have to kept in stock till you receive the next order for this the same type of product. So, in that context, overproduction, whether it is produced before the due date, just in time, Friday is just in time. If you are able to produce just on Friday at 3 p.m. only, then it is a good thing in JIT. So, as the if you are able to if you are producing early, then you have to keep it as a in the stock, and you need storage space, you need all the issues which are required in warehousing the item. Third is the motion, very important. Method too complicated. You have developed a system where a lot of complexity is there, lot of complications are there in the process. Simplify that process, simplify the process. See that steps are carried out in a very simple manner, combine the steps, broke the concept, find the new sequence also. We will study under the chapter on work study, how to simplify the work. There is one best method, we should try to find out that best method, which is very simple. There is no fatigue to the worker, we should see that there is no fatigue to the worker, there is no accidents, and there is no extra movement which has been carried out in this. Then housekeeping also, if there is a poor housekeeping, item is available, still you are not able to search it and you are purchasing, or on the workstation itself, you have kept all the tools etcetera in a jumbled manner, and every time you need a tool, you have to search the tool within that. Or second option is you have a well placed pegs etcetera, where all the tools are kept very nicely on a frame in front of you. So, that any tool required you can easily pick up, rather than they are kept all in haphazard manner in a box. So, poor housekeeping, we will talk about 5 S in this context. So, we have to follow the practices of 5 S housekeeping practices for the purpose of housekeeping. Another waste is waiting. If your material is waiting, or machine is waiting, or human resource is waiting, that is a waste. So, you should plan your activities in such a manner that material is receiving material is received in the plant when it is going to be fabricated. You want to convert it into the next stage. You are purchasing the casting when it is going to be machined, and you are doing the machining only when this machine components are going to be assembled. So, like this, and you are doing the assembly only assembled of this engine or some part when it is going to be into the main product, and you are producing the main product only when there is a customer. So, this is how we are talking about. There should not be any waiting of the material, it should be a smooth and rapid flow, starting from purchase of casting till the item is shipped to the customer. There should be smooth and rapid flow. So, that is what we are expecting in JIT, smooth and rapid flow we are expecting in JIT. Then same is true with the machines also. Machine should not be waiting, it should not be idle, very expensive resources. Manpower also, if you do not have the work, let them be deployed at some other place, they are doing some other activity, just like we have said that they are not to be retrenched, they are not to be fired, rather they can be used for adding their skills or doing some activity, or maybe doing the painting of the pipes and other things, or doing some painting of some areas, that can also be given to them, or they are working in the production area, they may be given skills of maintenance of the machine also, or they are doing the improvement of the machines, equipment, tooling etcetera also. Then there is a transport is also considered as a waste, transport is also considered as a waste. Any double handling, that means I will give you one example. Suppose this is your factory, a traditional factory, you are receiving the material, this is your material gate, from there material is going to the warehouse. So, this is your material gate, from there material is going to the warehouse. From warehouse, quality control people will come, quality control people will come, and they will take the sample from this material which you have received. They will inspect and give the OK report. Okay. Once that is done, now the material can be issued. Now, material is issued to a small store close to the assembly line. Suppose this is your assembly line, it is a bought out component, assembly line, bought out component. So, material is now from this place to it is stored here. So, material has come from this, the first handling, second handling is by the quality control people, third handling is you are moving the material to the one small store in the production area. From there it is kept to the trolley or place at the workstation. So, fourth handling. So, this is called multiple handling. The best solution for this is, but it required organizing the work. Best is if it can go directly here. So, in JIT we say that there is only single movement, one movement only, rather than having these 4 movements we should have single movement only. But this movement, this to be successful, to be implemented, what is required? There should not be any quality problem. Supplier is supplying you self certified item, self certified or vendor certified items. That means, vendor is taking the responsibility that I have checked and I am responsible for that if there is any problem with the product, with my item. So, second, the supplier should be, you cannot store 10 days of material near the line, it has to be frequent deliveries, frequent small lot deliveries. So, you have to develop your vendors close by, nearby, so that they are able to deliver maybe 8 times every hour or every 2 hours, they are in a position to deliver the material right at the point of application, point of usage. So, this is how double handling, multiple handling can be reduced. Excessive movement also, if your layout, we have discussed in the plant layout, process layout also, if your machines are not properly arranged, there may be lot of to and fro motion within the factory also. So, there may be excessive movement of the material within the factory also, material is moving forward, backward and so on. So, we should work out on a layout, so that there is no excessive movement of the material. Another important type of waste is inventory, which we are talking about. We are saying right from the beginning, inventory is a necessary evil. So, what is meant by now, if we say that, if we say the necessary is only evil, in JIT said it is not necessary, we can work without inventory also, or we should try to develop the system where we can work without inventory also. And we say that in JIT we say that inventory is a evil, we should not keep it. That is possible only if at the we are able to reduce the ordering cost. Even 1 unit purchasing 1 unit is also economical, my economic order quantity is equal to 1. I can purchase unit 1 unit itself is my economic order quantity. So, if I can do that, that is the best thing. Buffers are all types of buffers is also waste. Buffers are kept because of uncertainty, because of variability in the systems. Variability can be due to machines, it can be due to supplies, it can be due to demand also. There are other sources of variability can also be there in the system. So, if we are able to reduce the variabilities, we can eliminate the buffers also. Large batch sizes is also one of the issue, like this is a workstation. This is a workstation where worker is working and you have decided to produce in a batch size of 100 units. So, this is your trolley where the material is lying. So, 100 unit. You are working on the 1 unit, out of this 1 unit you are working, remaining 99 are waiting, and on this side you are shifting to it. So, at any point of time you are finding, except 1 unit is in working, 1 unit is under value addition and remaining 99 is waiting. Okay. And why we are producing in large batch sizes? Because of the high change over time, high change over time, high setup time. We have seen our economic batch quantity formula. If there is a higher change over time, we have to, there is going to be the large batch size also. So, if somehow if I can reduce the change over time, we can very easily work out with the smaller batch. If I am able to reduce from 100 to 10, that is going to be achievement. And that is how we should try to work out here in this case to avoid the production of large batch sizes, I should be able to produce in the small batch sizes. That is possible only with reducing the changeover time. Let me give you some idea about this. Suppose this is your power press, where it is a let us say car manufacturing company. Car manufacturing company. So, this is a power press, and on this you are producing 4 types of components, 4 doors you are having: front left door, front left, front right, your rear left and rear right. Okay. So, you are doing the batch production system here, and then you are getting it. Suppose you have decided to produce a batch size of 500. So, you produce 500 of front left, then you make a changeover, you produce 500 here, then you produce 500 here, and once this set of 5000 set are available, then it will go to the next station of welding or painting. Okay. Now, like this, why we are producing a batch size of 500? In that case, lot of inventory get accumulated here. Okay. And it may also happen that by the time you are producing this 500 sets, there may be a change in the requirement from the assembly area. They may say that there is a change in the assembly now from the market, but you do not have the flexibility to do that. You have, unless you produce all the 4 parts in 500 quantities, the sets are not complete. So, it will not be able to use it. Now, why we are producing in such large batch sizes? Because at our power press, the changeover time may be 4 hours. The changeover time is 4 hours or 8 hours. So, if I am making a change over 4 hours, I want to run this machine for at least 6 hours, 8, 10 hours continuously. So, in that case, why this changeover time is 4 hours? Because in this case, you are making the changes. You are making the changes within these small adapters are there, or small components are there. You are doing the changes in that components and parts, and then that takes lot of time in setting, adjustments, etc. The changeover time is production of the last good item of the previous batch to the production of the first good item of the new component. So, that is the kind of a thing which is there, that is why changeover time is 4 hours. But Japanese did in this case. They said that there is no need of making small changes in that. Rather, they said this is the die, this is their power press, this is the die in between you were changing, making the changes. You say that you replace this die, this is the die for let us say your front left. Rather than making the changes in this front left die and making it suitable for front right, you shift it to the outside and let this take the place of here. So, whole of the die is shifted, and there is a rail there at the bottom of this dies. So, that it can be shifted in 10 minutes only. This whole changeover can take place in 10 minutes or less than 10 minutes. Only thing is you have to push this die to one direction, and from the other side another die is taking its place, and the die is planned in such a manner that they will get press fit without any adjustment is required. All your fastener, clutches, etc., in such a manner that it will take its place without any adjustments required. So, if you are able to reduce the changeover time from 4 hours to 10 minutes, maybe the 5 units is the your batch size of 5 is also good enough. 4 hours means 240 minutes. So, now you can divide this 500 by 24. So, that is kind of a change you can bring it in your batch size. You can drastically reduce the change over time, though it will come with the formula. It may not be as simple here, but definitely by reducing the change over time, you can reduce the batch size also, and by reducing the batch size, you are bringing the flexibility also in the scheduling. If there is any change in the manufacturing process you want to bring, you can very easily bring within a half an hour or 1 hour. 5 of each type you may be able to produce in 1 hour. So, you every hour you can have a new production schedule which is coming from your assembly area. So, that is the concept of inventory, batch size, flexibility, etc. It will become more you will become more competitive also. Being flexible, you will be more competitive also. You can change your production plans very easily if you are having a small batch size production. Now, look at the another type of waste, which is called the process waste. If your process is too big, you have to produce 200 units per day, but your manufacturing machine is having a capacity of 500 units per day. So, it will consume more space, it will consume more energy also, more maintenance cost also. So, that will become, that is a waste. If it is too fast also, that is also a waste. If the variability is there in the time, in the quality, in the operation time also, then also it is a waste. If the equipment require high maintenance, that itself is a waste. So, what we should do? We should replace it with the right size of the, replace it with the right size of equipment, right size, right capacity, right speed and maintenance free, highly reliable. Replace it with the right size and reliable equipment process. Okay. So, this is how we can look at this waste. So, these are some of the waste which are there in the inventory system, in the JIT system. We recognize them as the waste. Now, we will see that how to eliminate this waste with the help of, though I have given, along with defining the waste, I have given you the idea also what is being done in the organization to get rid of this waste or to reduce the size of these wastes. It is not possible to eliminate completely. Our tendency should be to, it should keep on, we should continuously keep on reducing it. So, we will continue on this in our next session on JIT manufacturing, where we will talk about Kanban system, we will talk about value stream mapping also, very important tools in JIT manufacturing. So, with this, thank you very much. We close this session here. Thank you.